My name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 288. Please turn to page 288. Today is our lesson number 202, and the problem that we are about to solve is 144. The very last problem in the first column. It says, are all the numbers in a list of 15 numbers equal? First statement tells us, let's see what they tell you in the first statement on 144. It says sum of the numbers in the list is 60. Simply knowing, okay, if I come up to you and I tell you that I have a box here with numbers written on a piece of paper there, and if I tell you that their sum is 60, are you able to tell from there if all those numbers happen to be equal? Of course not. Simply knowing the sum of the numbers is not going to tell us if they are equal or not. First statement is not sufficient. A, D, B, C, E. This is a strange problem because there's not much really I can do here, because you just have to think about it. It's a very straightforward problem. There's not much in here. So simply knowing the sum of the numbers does not actually enable us to say for sure if the numbers are equal. They may be equal. They may not be. Who knows? You may have the sum of the 15 numbers. They may all be equal. Who knows? They may not be. All we know is that there are 15 of them. For all we know, there might be 14 0 and 160, and their sum would be 60. Or there could be a whole bunch of negative numbers and then just one huge very positive numbers. Who knows? It's not enough. Let's look at second statement. The second statement tells us the sum of 144, sum of any three numbers in the list is 12. All right. The sum of any three numbers equals any three numbers equals 12. Now what does that tell us? Knowing the fact that if you were to pick three numbers at random, you put your hand in that box and there are 15 numbers on a piece of paper there, and you put your hand in the box with your eyes closed, and you pick three numbers at random, and you read those numbers and you add them up, you get 12. You repeat the experiment, you pick three numbers at random again, and you add them up, and they happen to be 12. You repeat the experiment one more time, another time, no matter how many times you repeat the experiment, the sum of the three numbers is always 12. What do you gather from that? One very simple conclusion that one arrives at, and that conclusion is that all of those numbers, all of these 15 numbers, all of them must be 4. They must all be 4. Which is how we get the sum of three numbers to always be 12. Because we are just picking numbers at random. It could be any number, and yet you repeat that experiment 1,000 times and still the sum is always 12. That's because you're reading a whole bunch of 4s. Every time it's 4, 4, 4, you add them up, you get 12. You repeat the experiment one more time, again you pick three numbers at random, and they're all 4s. And therefore, they are all equal. The question was, are the numbers in the list equal? The answer is yes. And therefore, the second statement is sufficient. We found that the first statement was not sufficient, and I never finished it. Because the first statement we found to be not sufficient, therefore we knew at that point that the answer could not be A or D. Answer at that point we knew had to be either B, C, or E. Now we know that because the second statement works, the answer is B. Not because, when we said the second statement works, not because Hans' answer happened to be yes. Are all the numbers in the list equal to 50? Are all the numbers in the list of 15 numbers equal? The answer is yes, they are all equal because they are all 4. But that's not the reason why we say second statement is sufficient. We say the second statement is sufficient because we are able to tell the answer, we are able to answer this question definitively, either in affirmative or negative. Even if the answer turns out to be no, it will still be sufficient. We are able to say yes or no. Let's do the next question, shall we? The answer here is B. That's it. Answer is B. Let's do the next one. This was too silly. I don't know how you feel about it, but that's my opinion. The question was too silly. Obviously, they will have to be all equal. If you pick three numbers at random and their sum always happens to be equal to 12. How do they phrase it? The sum of any three numbers in the list is 12. Well, then bloody hell, they're all 4. 145. We are given an equilateral. Let's draw the equilateral first. It looks something like this. Oh, not equilateral, sorry. Quadrilateral is what I meant to say. Is that line mine, or is it in the, yeah, it's in the picture. This is 60. This we are told is 45. This is 15. This is what they're calling R, S, T, and U, and W. And we are told that it is a 90-degree angle. In other words, this line that we just dropped is perpendicular. We are dropping a perpendicular from S to the bottom. And that's about all we are told. Apparently this is a layout of a parking lot, and our job is to figure out, the question here is, do we have enough information to figure out the area of the parking lot, and to which we have to be able to answer either yes or no. Let's find out what they tell us. So RSTU, we are told, is a quadrilateral. And RU, R to U, we are told, is parallel to S to T, which is a very important information. Otherwise, this problem will not be able to, we would not be able to solve it. And we are told that RU is longer than ST, which I'm not going to put on the blackboard. As you can clearly see, it is. Question is, what's the area of the parking lot? Let's see what they tell us. In the first statement, they tell us that R to U is 80. Is that all they tell us? R to U is 80. Yeah, that's all. If R to U is 80, right here, okay, listen carefully. If R to U is 80, then because of the fact that if you were to drop another perpendicular here, if S to T is 45, then W to, let's give it a name here, let's call it R, S, T, U, V, and W. If S to T is 45, and because we just dropped a perpendicular, W to V must also be 45. And we are told that R to U is 80. If R to U is 80, this is 15, this is 45, 45 plus 15 is 60, V to U must be 20. So far so good. So far so good. And V to W to U is 65. There you go. That's it, we are done basically. Now we want to find the area of the parking lot, which is very simple. Area of the parking lot would equal area of the first triangle, triangle RSW. And we can figure out the area of the triangle very easily because we know the base and the height is 1/2 base times height. We can figure out the area of the parallelogram, not parallelogram rather, a rectangle, WSTV, and we can figure out the area of the triangle TVU. There you go. All of those can be very easily calculated because this from here to here is also 60. That's it. The first statement by itself is enough. First statement by itself does the job beautifully. AD, BCE. Because the first statement we just found out is sufficient, we know now answer cannot be B, C or E. It will have to be either A or D. The part that we are about to do is something that we will not be silly enough, we will not be foolish enough to actually waste our time in the real exam. Let's just do it out, just for the practice, shall we? Well, it doesn't hurt. It doesn't hurt to learn something, get some more practice, get some little extra practice. So triangle RSW is 1/2 base times height. RSW, the base is 15 times height, which is 60. You cancel out 60 with the 2, and it's 15 times 30. 15 times 3 is 45, so it's 450. triangle TUV, again is 1/2 base, which is 20, times height, which is same as before, which is 60. Now we can cross out the 2 with the 20 here, and it's 600. Very straightforward, very simple. And finally, the area of the rectangle SDVW, it is simply 45 by 60. And whatever that happens to be, 45 times 60, you add up these three figures and that's the area of your parking lot. Very straightforward, very simple, as we said. And of course, we didn't have to do it. We did it because we like math so much. You understand? Let's do second statement, shall we? Let's see if second statement gets us anywhere. In order for us to work on second statement, we must erase everything that was given in the first statement. All of this 15 was given to us in the problem, but this was something that we gathered from the 80. We have to erase this part. The rest can stay. The rest can stay because the rest can be extracted from the picture itself. And the second statement that tells us that T to U is 20 times the square root of 10. Where is T to U? Oh, right here. T to U is equal to 20 times the square root of 10. Well, that's also very straightforward because once we know that's the hypotenuse in the triangle, TUV, and again, in the real exam, obviously we're not going to write anything, we're not going to analyze anything, and we're not going to actually calculate anything. You just have to quickly analyze it to understand whether or not we have sufficient information, and we do. We know this side, which is 60, we are just given the second side, the hypotenuse. Obviously, if we know two sides of the right angle triangle, we can figure out the third side very easily by a simple application of Pythagorean theorem. Once we have U to V, we can figure out what W to V to W must be. Because based on the fact that then what that's just 45. What the hell? That's just 45. That's it, we're done. This is 45, this is 15. Once we figure out that side, we'll know enough information to figure out the area of all of those three parts, and second statement is also enough. Second statement is also enough. The answer is D. Again, just for learning purposes, we're going to actually do it out. Not for the exam, but just for the hell of it. As one might put it so eloquently. So in triangle, you know what, we're not going to actually do that because I don't have it done here. If you want to do it, if you're hell-bent on it. So that's, they tell you, I don't know why I said T equals to, it's T to U, not T. T does not equal anything, T is just a point on the picture. So that side is that, let's call that side X. Well, let's not call that side anything. Let's call this side X. So therefore, we will have X squared, which is this part right here, plus 60 squared equals, I want to find out how complicated it is, equals the square of this quantity, which is 20 times root 10 squared. 20 times root 10 squared would be 20 squared, which is 400, and square root of, and the square of 10 is just 10, so it's 400 times 10, or 4,000. What the hell? 4,000. And this will be 3,600 x squared. Therefore, x squared will be 4,000 minus 3,600, or 400. And therefore, x will be 20. Oh, there you go, just like before. And just like before, once we have the x, we'll repeat the exact same procedure, nothing different, until we'll know the area of the parking lot. Now, if you give me 1 second just now, I want to see the back of the... No, I'm not going to do the next one. The next one is nasty. Next one is going to take some time. I was going to do one more, but I'm going to save it for tomorrow, okay? Otherwise the video will be too long. I'll see you tomorrow, okay? Bye now.